Okay, so welcome back to another video. So in today's video, we actually got a combination of both a product series and an integral combined together. So we have the product series from our starting index k is equal to 1010 to 3029 of the integral of 0 to pi over 2 of the 1010 root, I'll just say that, of 2 to the power 1010 minus k multiplied by sine of 2x to the power k, and then dx with that integration. So this is just a jumble of stuff like combined together as one, but it's gonna come down interesting as we're actually gonna be using some gamma functions and simplifying all with that as our answer. How about first I rewrite our integral expression inside. So therefore we have that this entire expression will be equivalent to, let's see, 2 to the 1010 minus k power of sine of 2x to the power k, and then to the power 1 over 1010. Okay, now if we simplify this out, now what I'm meaning, like if I just distribute the 1 over 10 the exponents to everything inside, since it's a product. So notice that since there's a base 2 with 2 to the power 1010 minus k, I can split that up for our same basis. So this is 2 to the power 1010 multiplied by 2 to the power negative k. And now I distribute the exponents. This is just 2 to the power 1. Okay. And then multiply by 2 to the power 2 to the power negative k divided by 1010. And then just simply multiply our sine of 2x to the power k divided by 1010. Now, if I just simplify this out, then so 2 to the power negative k divided by 1010, so it's negative exponents, so rewrite this in fractions, just 1 over 2 to the power k over 1010, but they also share the same exponent, so I can combine it together. So other words, we get that this is 2 times sine of 2x divided by 2, and then to the power k divided by 1010. Okay, and now I can actually just distribute this back with our rewritten expression. So that means we have that this is the product series, and then we have that this is the integral from 0 to pi over 2 of 2 times sine of 2x, and then divided by 2, and then to the power k divided by 1010 dx. Let's actually integrate this. So let's actually use a little identity in order to make this integration a little easier. So let's note that I want to use the following identity. Sine of 2x divided by 2 is actually equal to just sine of x multiplied by cosine of x. Okay, and with that, then we can just replace with our substitution. We get that this is, so rewrite the product series again, and our integral 0 pi over 2 of 2 times, well, okay, and I can actually factor out the 2 outside. So since that's just a constant, so this is just 2 times the integral 0 to pi over 2 of, so substitute back in, so it's sine of x, cosine of x, and then to the power k divided by 1010 dx. This is not going to be easy to integrate, but how about I manipulate this our integrand just a bit. So what I'm going to do is I'll actually factor out a sine x cosine outside, but not only that, that's actually going to change our integrals, like the exponent power as well. Okay, so when I do this, let's see, just rewrite the same thing. So this means I would get so sine of this will be sine of x to the power k divided by 1010 minus 1 of x, then cosine of x to the power k 1010 minus 1 of x, and then factor that out with our sine of x, cosine of x, dx. Let's actually do a u substitution. So how about I do this substitution in orange. I'm actually going to let u equals sine square of x. Okay, so then if I were to take the integral, if I take the differentiation of both sides, so I get that this is du, and using chain rule, so this will be 2 multiplied by sine of x, and then multiplied by the input, the derivative of sine of x, so that's just cosine of x. So we get that this is 2 times sine of x times cosine of x. Okay, but also don't forget that I need to substitute everything in terms of u. So okay, let's do things this way. So how about I take the square root of both sides, so that means I'll get I'll just write it in terms of exponents. So u to the 1/2 is equal to sine of x. Okay, and now with that, well, let's focus on just the trig function of sine of x for a little bit in a sec, and then we'll get to the cosine later. So we have that sine of x, and then we have the power k, 10 minus 1. So we have that's supposed to equal in terms of sine square of x. And then I want to replace that with everything in terms of u, okay? Because sine square of x is from here, so that means if I want to get just u by itself, then I can just replace our sine of x with just u. So that way I have that this is u to the power 1/2, and then to the power 10 minus 1. And so that's just equal to sine square of x. Okay, and that means I'll just distribute distribute the k over 10 minus 1 to the 1/2, and then we'll get that this is k divided by 20, and then minus 1/2, and so that's equal to sine square of x. So that means everything for sine square x will be replaced with u, k, and then 20 minus 1/2. Okay, so now let's just substitute everything back in. Okay, so now rewriting our new integral. So this is 3029, and then k is equal to 10. So we get our new integral. So notice that du equal to sine x cosine x, they cancel. So that means sine of k over, that means I'll just replace this in terms of u. So this is u to the power k divided by 20 minus 1/2, and then replace with cosine x. Well, we know that we know the trig identity 1 minus sine square of x equal to cosine of x, and so I'll just replace that and replace the sine square x with u. So then really we have that the following substitution is 1 minus u, and then substitute back with our new exponent in terms of u. So it's k to the power 20 minus 1, and then du. Now let's actually change our index a bit. So that means how about I draw this little arrow over here so I know that the next step is what we're doing is we're changing our index. So we change our index. So let's say our index, we're gonna let k minus 10 equals n. Okay, so when we do that, so I substitute everything k from here. So that means our starting index here would be k is equal to 0, and then our upper index. So what is it? 3029 minus 10, so that's should be 2019. That should be 2019, and then also I forgot to write over here that we have our new bounds of integration. If we let 0 equals x, then that's going to be 0, and then if we let x equals pi over 2, so sine square of pi over 2, that's actually going to equal 1. Okay, so change the index, so our new bounds 0, 1. And then we also have to change our exponents over here as well. So actually when you plug this when you plug the exponent back in our change of new change of index, you're going to get that our new exponent over here is going to be n to the power n divided by 2020, and then multiply with 1 minus u of n divided by 2020, and then du. This probably looks a little difficult to integrate from there. So actually, we're actually going to use something very interesting, and that is we're going to use the definition of a beta function. So the beta function, I'll just write capital B of our inputs x, y. It's defined as the following integral. So this is the integral from 0 to 1 of t to the power x minus 1, and then multiply by 1 minus t to the power y minus 1 dt. Okay, and that's for width. I'll put it like this. So the real part of x has to be greater than 0, and the real part of y has to be greater than 0, such that for x and y are the complex numbers. We have this little form here, and actually another property I'd like to state is that also the beta function can be defined as in the following form of the gamma function. So it's defined as the gamma of x multiplied by the gamma of y, and then divided by gamma of x plus y. Okay. So now let's actually just use our formulation here from this integral and replace this in terms of with our gamma function that's defined from our definition of a beta function. Okay. So if I were to say, so let's see, gamma x, let's say, in this case, let's see, so x is from here, so that means we let the exponent equal to this exponent if we equate each other. So let's see, this is x minus 1, and then n to the 2020 divided by 2020. So pretty much that would have to mean that this is equivalent to gamma of 1 plus n divided by 2020. But now let's find what gamma y is. So gamma y is over here, so it equates to here. So y minus 1 equal n to the 2020. And when you look at that, it's actually the same thing as 1 plus n over 2020. So we can see that this is also equal to gamma y as well. So therefore, the beta function of this integral over here is actually going to equal to, let me put this back in red, and I'll just actually write this integral again just for it. So that means our integral 0, 1 from the power u n divided by 2020, 1 minus u, and then n to the 20 divided by 2020 du. That's actually just equal to let's see, so gamma x and then gamma y, so just multiply these two, they're the same thing, so this is gamma square of 1 plus n divided by 2020, and then gamma of x plus y, so they're the same thing, so it's 1 plus n over 2020, then plus 1 plus n over 2020. So we divide this, so this is gamma of 2 plus, so let's see, so 2n and then 2020, so simplify that out, we get that this is n divided by 1010. Okay, so that's our integral over here, and let's see, just plug this back in. Okay, so let's just reiterate from over here. So let's see, this is the product of 2019, then k is equal to 0 of our integral 0, 1 of u n divided by 2020, and then 1 minus u. And so that's equal to our product again, k is equal to 0. And then replace this with our evaluated beta function, which is defined in terms of gamma. So this is gamma square of 1 plus n divided by 2020, and then divided by gamma of 2 plus n divided by 1010. So that's what we have so far. So now let's actually evaluate this. How about let me first rewrite this a little bit differently in terms of products. So we have that this is, let's see, product of 2019 k is equal 0 of gamma 1 plus n divided by 2020, that's square, and then multiply with the product again of 1 divided by gamma of 2 plus n divided by 10. So now we just have to evaluate these two product series. Now I'm not going to go over the proof of this little formula we're going to use. There's actually plenty of resources out there, and I think there's probably even a YouTube video out there that goes over this derivation. But this is the formula we're actually going to be using specifically is known as the Gauss multiplication formula, and that's defined as the following. So this is defined as the product series of our upper index n minus 1 to k is equal to 0 of the gamma of z plus k divided by n, and so that's actually equal to n to the power 1/2 minus n times z, and then multiply by the gamma of n times z, and then multiply by 2 pi to the power 1/2 n minus 1/2. I just wrote it in decimals since it's just easier that way, especially when we're calculating with big numbers here. Okay, so we have that. Now let's actually calculate our both our product series using the Gauss multiplication formula. Yeah, I'll actually stick with orange this time. Okay, so first let's calculate our gamma of 1 plus n of n divided by 2020. 19 k is equal 0 of gamma 1 plus n divided by 2020. So that'll be equal to, so let's see, our n is going to be 2020, our z is equal to 1. So I mean this is 2020 to the power, let's see, 0.5 minus n times z, so 1 times 2020 is 2020, and so 0.5 minus 2020, that is negative 2019.5, and then multiply with our gamma, the product, so this is 2020, and then multiply with 2 pi, and then the product, let's see, 0.5 times n, which is 2020, 0.5 times 2020 minus 0.5, let's see, that's gonna come down to 1009.5. Okay, so that means if I were to continue this further, if I evaluate this square, since we have that this is the product series of gamma 1 plus n over 2020 square, so let's see, if I fill this back in, so 2020 negative 2019.5 gamma 2020, let's see, 2 pi 1009.5 square, then this will equal to 2020 to the power negative 4039, and then multiply by gamma square of 2020, and then square over here. So let's see, 1009.5 multiply that by 2, so we get that that's actually just 2019. Okay, so now next let's calculate our gamma of, or our product series of k equals 0 to 2019 of 1 divided by this gamma. Let's focus on just calculating the denominator, so the gamma. So let's see, over here, this is gamma, or hold on, let me write 19 k is equal 0 of gamma 2 plus n divided by 10. We can't really use Gauss's multiplication formula to evaluate this product specifically because it's not in the format that we're by its definition. So what we can do is we can actually rewrite this this gamma function over here, or rather the product series itself, by fixing the index up a bit. So how about instead let's fix this. So how about when we'll multiply this as a product of product series. So we let this, why would we let our first index be from k is equal to 0 and then all the way up to 1009, okay? And then the same thing with gamma 2n plus n 10 10, okay? And now we want to multiply this with the product. So this is from 2019. This time our k is going to start at 10 10. Okay, and we also still get that this is so we actually have that the product k is equal to 1010 to 2019, and so this is gamma of 2 plus n divided by 1010. But also from this product series here, it's not the same formulation of the Gauss multiplication formula. So therefore I'll have to rewrite this even a little further. So that means what I'm going at is trying to change the index. So let's see, 1009, k is equal to 0 of gamma 2 plus n divided by 1010, and then multiply with our gamma again. So we actually change our index again. So let's see, k is equal to 0. And then we're gonna go to 1009. But that also means that we have to change our input of gamma. So that means, let's see, 10 here. So that means this actually has to be 3 and then plus n divided by 1010. So we actually have two formulas we're gonna calculate. Okay, so now let's actually calculate these two formulas, these two product series using the Gauss multiplication formula. So now I write in black, since we got two we're going to calculate. So let's see, I'll just put a little star here, just put out front. So let's see, product of 1009, k is equals 0 of gamma 2 plus n to the power 1010. Okay, so using Gauss's multiplication formula, we're gonna get that this is, so we let z is equal to 2 and then n is equal to 1010. Okay, so we get that this is 1010, we get that this is the power negative 2019.5, and then multiply with our gamma of 2020, and then multiply with 2 pi to the power, let's see, so 2, and then this will be 504.5. Now let's calculate our other gamma, which is gamma, or the products, let's see, 1009 of gamma of 3 plus n to the 1010. So that means this one, we're gonna get that this is 1010 to the power, let's see, and then this will be negative 3029.5, and then multiply our gamma, so this is 3030, and then multiply with 2 pi, and then to the power 504.5. So we have these right with gammas right here. Okay, now let's go back and substitute this back. So therefore we have that from over here, this is going to equal to, let's see, so this is the product, give me 1 second. Okay, so now we have that our products of those gamma functions, we evaluated them. So now when we multiply the two together, so basically this is actually some of them have the same base, so this is combining exponents. So this means this is negative 2019.5 plus negative 3029.5. That's going to give us, this is going to give us 1010 to the power negative 5049, and then multiplied by the gamma of 2020, and then multiplied by our power, let's see, 2 pi, so 504.5. So that's going to give us 1009. So 2 pi 1009, and then multiplied by gamma to the gamma of 3030. Okay, so we have both our underlying reds, our calculated product series of the gammas, and then we can just put everything back together. Okay, so now let's reiterate back. I'm using red this time. Let's go back. So to reiterate over here, so I'll just rewrite the series again, the product series again one more time. Of so gamma of 1 plus n 20 20, and then multiply with our product of 1 divided by gamma of 2 plus n to the power 10 10. So simply that's just equal to, so this is basically our numerator and that goes on to our denominator. So give me a sec to write this out. Okay, so we put everything together, we get that this is our numerator from here and then our denominator is here. But we can actually continue on and simplify this out a little bit. What I can do here is I can actually decompose our base 2020 with 2 times 1010. So let's see, so this is, so we have that's 2 to the power negative 4039 multiplied by 1010 to the power negative 4039. And so let's see, the gamma squares, so gamma square 2020 and then gamma 2020, that cancels. Well, we're only left with 1 gamma 2020 on the numerator. So this is just 2020 and then multiply with 2. Yeah, and then we're also left with, so we have 2 pi 2019 and 2 pi of 1009. So if you subtract those exponents, we'll be left with 2 pi, and then the numerator should be just 1010. And then under the denominator, we have that, so we have 1010 to the power negative 5049, and then multiply with gamma 3030. Okay, and even further simplification. So let's see. I distribute. So let's see. There's a 2 negative here, so that means 1010. So that means in the numerator we get that this is 1010 to the power 1010, and then multiply with our gamma 2020, and then multiply with our 2 pi 1010. And then since this is 2 to the negative 4039, I'll just move that to the bottom and then multiply with gamma 3030. But I can also simplify this even further since they both share the same base. And I can actually simplify the base 2 down with here as well. So therefore, further simplification, if I just skipping some steps, we'll get that this is 1010 times pi to the power 1010. Then multiply with gamma of 2020, and then divided by 2 to the power 3029, and then divided by or multiply by gamma of 3030. Okay, and there we have it. And that's our final answer and the conclusion of our integral. Well, our product of an integral in this box right here. All right. Now that's pretty cool if you ask me.